Hi everyone, my name is Mert Kağıtçıoğlu and I'm a freshman student at Industrial Engineering Department at Bilkent University. Today I will present my Physics 102 lab project. In my project, I explored how the dropping height of a magnet affects the maximum induced voltage in a coil. My aim was to understand how motion and electromagnetic induction are connected through Faraday's law. So now let's understand what the Faraday's law is. According to Faraday's law, the induced voltage or electromotive force is proportional to the rate of change of magnetic flux through the coil. This relation is described by this equation. In my setup, as the magnet falls through the coil, the magnetic flux changes rapidly within a very short time. The velocity of the magnet increases with the square root of the dropping height. Combining this with Faraday's law, we can expect that the induced voltage also increases with the square root of the height. This theoretical relationship forms the basis of my experiment. For this experiment, I used a copper coil with 1800 turns and a neodymium magnet, a weight of 28.76 grams. At the beginning, I want to check if my setup works as it should. So I moved the magnet back and forth near the coil to see if any voltages was generated. The multimeter showed clear voltage changes, which means everything was ready for the experiment. For the first drop, the magnet was released from 5 centimeters and the induced voltage was recorded as 9.7 volts. In the second drop, the magnet was released from 10 centimeters and the measured peak voltage increased to 20.8 volts. For the third trial, the dropping height was 15 centimeters. This time, the induced voltage reached to 96.7 volts. And finally, the magnet was dropped from 20 centimeters. The peak voltage recorded was 141.3 volts. After recording the experimental peak voltages, I calculated the theoretical values using the formula based on Faraday's law and kinematics. This table shows both the experimental and theoretical results, along with the percentage error for each height. As seen here, the error is much higher at lower heights, especially at 5 and 10 centimeters. This is because the multimeter struggles to detect the fast voltage peaks at low speeds. However, at higher heights like 15 and 20 centimeters, the experimental results are much closer to the theoretical ones, confirming the expected square root relationship between height and induced voltage. In conclusion, this experiment showed that the maximum induced voltage increases with the square root of the dropping height, as predicted by Faraday's law. Despite some measurement errors at lower heights, the results supported the theoretical expectations. Thank you for watching.